Scanner School session number 55, an introduction to DMR.
Welcome to the Scanner School, a podcast dedicated to the scanner radio hobby. Class is about to begin. Here is your host, Phil Lichtenberger.
Welcome to Scanner School. My name is Phil Lichtenberger. My amateur radio call sign is W2LIE, and this is Scanner School, a podcast where we teach you everything you need to know about the scanner radio hobby. And as always, this podcast is sponsored by East Coast Pagers. East Coast Pagers is a Unication, Apollo, and Swiss phone dealer serving the U.S. market. East Coast Pagers sells numeric and alphanumeric paging products, as well as today's most advanced voice pagers used by many fire departments. When you purchase a Unication or Swiss phone pager from East Coast Pagers, shipping is always included. Now, the Swiss phone pagers and Unication G4 and G5 pagers all ship with spare belt clips. The Unication G1 pagers will ship with spare belt clips and a spare set of Tenergy AAA batteries. Complimentary programming of your department's dispatch and fireground are always included. You can contact eastcoastpagers.com for a custom quote for your individual or department needs. Again, that's eastcoastpagers.com. Now, I also want to remind you that all session notes, and there's some graphics for this one, can be downloaded by going to scannerschool.com/session55. So DMR. DMR stands for Digital Mobile Radio. Now, in the past, we've talked about P25 and NXDN. DMR is similar and also very different. And today's podcast is an introduction to what DMR is. So as we've talked about with P25 and NXDN, there's going to be a intro podcast followed by a trunking podcast. So today we'll talk about the foundation of DMR, conventional use. So in next week, we're going to talk about trunking. This week we'll stick mostly to the theory and the conventional side of what DMR. So DMR is an open standard that was created by the European Telecommunication Standards Institute, also known as the ETSI. So like where NXDN, we had a NXDN forum, which was made up of 30 members. DMR's got their own flavor, and it's called the DMR Association. The DMR Association has 40 members, and they include big brand names such as Kenwood, ICOM, Motorola, Tate, and Hytera. There's a whole set of standards here, and of course, the DMR Association wants to sell the end user on using DMR. So they've set up a whole list of benefits as to why somebody would want to invest their money into a DMR setup. So some of the standards would be, or some of the features of DMR are that it's a security or supply through an open standard, superior audio performance as compared to advanced control features, system flexibility through simultaneous use of TDMA channels, which is the same as P25 really, the ease of use and creation of data apps, longer battery life, which I am assuming is longer battery life compared to analog, efficient use of infrastructure equipment, backwards spectrum compatibility with legacy systems, and that you can double the capacity of existing licenses. So like the double the capacity of existing licenses means that you can really fit 2 transmissions on the single 12.5 kilohertz license. And we're going to talk about this and how and why in a second here. So before we do that, I want to talk about some similarities here between NXDN, DMR, and P25. So like the previous two, DMR uses the proprietary AMBE plus 2 vocoder that's manufactured by DVSI. Again, we talked about with analog, we've had PL and DPL. P25 uses NAC. NXDN uses RAN codes. DMR also has their own flavor of signaling squelch, and they are called color codes. So again, we're seeing a lot of similarities, a little bit of difference in terminologies here. But again, DMR is a digital-only mode. You will not find any analog transmissions on DMR. Just like P25 and NXDN, DMR also supports encryption. Your basic encryption is 255 pre-selected 16-bit keys. Enhanced encryption includes 40-bit kids or over 1 trillion combinations. So one thing that sets DMR apart a little bit is a RAS, or a radio access key. As a scanner user, we don't really have to worry about RAS keys. RAS is basically there to prevent somebody from getting onto a system with an unauthorized radio. All right. As a listener, we can ignore the RAS code. And RAS is not there for encryption. RAS is just there as a authentication to be able to get onto the system. So again, if you need to go back and you want a refresher, you can listen to scannerschool.com/session 14 and 15 to review P25, and scannerschool.com/43 and 44 to review NXDN. Okay, so like P25 Phase 2, DMR uses TDMA, or Time Division Multiple Access. So I want to take a minute here just to review what TDMA is. So TDMA basically means that you're splitting the frequency in half because the timing is alternating between user 1 and user 2. So instead of having somebody key up the radio and use the frequency at all time, you're splitting in half over time. So it's alternates 1 2 1 2 1 2 1 2. So this is how DMR is saying that they're doubling the capacity of the existing licenses, and how they're making efficient use of the infrastructure that's already there on your license, because basically they've doubled the capacity due to TDMA. The radio is also on a half-duty cycle because it's transmitting on every other time slot. So they're also saying, too, that you can increase the battery performance. I've seen numbers about 40% on the increased battery performance. So remember, we're talking digitals, we're talking packets, we're talking data, and now we're talking about a difference over time, right? 1 2 1 2 1 2 1 2 1 2. How do we know what time slot we're listening to, or that we're actually in sync? Because these are all going by in milliseconds. Well, just like P25 and NXDN, there has to be some sort of formality when it comes to the data that's going out over the air. Part of that data is a synchronization bit. And that's how the transmitters and the receivers can sync up and align themselves, is they all look for that sync bit. Now, in a typical DMR signal, a sync bit is smack dab in the middle of the packet. It's about 5 milliseconds long. The typical data burst on DMR, just so you know, is 30 milliseconds. So we are talking really fast timing here, right? Faster than the human ear can hear. That's why when you're listening to a DMR transmission, you don't notice or hear a break in the conversation as the time slots change, because this is happening really fast. So the typical TDMA signal is built as follows. A catch, which is a CACH, is a common announcement channel. Figure that as building the first building block of this signal. The second is the payload, which is time slot 1. Then we have a sync packet. Then we have a time slot 1 packet again. Then we have, again, the catch, or the common announcement channel sync. And then the time slot 2 payload, time slot 2 sync, time slot 2 payload, and another catch. And that system just recycles itself over and over and over again. So what's interesting about DMR is, because it's TDMA, you can also go full duplex. So time slot 1 could be you transmitting, and time slot 2 could be somebody transmitting back to you. So that's really cool, because now you can basically have a full duplex conversation as if you were over the phone. Okay, we'll be right back after this quick announcement. People have been asking me for a while where it is that I buy my scanner radios and equipment from. Well, I want to let you know that I buy my equipment from Scanner Master. I love dealing with Scanner Master. They're right out of Massachusetts, so they're really local to me. I usually get my packages the next day, which is better than Amazon Prime, basically. But they do ship worldwide, and they've been in business for over 40 years. So they've been around. They know their stuff. So when it comes to buying a new scanner, new antennas, just accessories and general cases, I always go to Scanner Master first. And if you go to scannerschool.com/scanner Master, that's a great way to help out the Scanner School podcast, because we will make a small commission on anything you buy from Scanner Master. So again, my recommendation on where to buy your next gear is from Scanner Master. Go to scannerschool.com/scannermaster. So DMR is capable of operating at a 4-state FSK modulation, FSK being frequency shift keying. So I'm going to kind of draw you a mental picture on this one. If you were to envision a cross in your head here, you have 4 quadrants, right? If you were to put a symbol at every 45 degrees, so like one at 45, one at 135, one at 225, one at 315, basically you're splitting each quadrant in half, right? Those would be the roundabout points of where your symbol is located in FSK. So the over-the-air symbol rate is about 4,800 symbols per second, or 9,600 bits per second. Now, after we have all the overhead messages, all of the error correction, and everything else that needs to happen in a signal for DMR, there's probably about 2450 bits per second left for voice traffic. So we're losing, about half of the available bits just on upper traffic management and error correction. Half of it is available for voice traffic. Now, P25 has got 4,400 bits per second per time slot. So there's a lot more data available for voice on P25 than there is on DMR. So as we stated earlier at the beginning of the podcast, DMR is an open standard, but many manufacturers have added their own proprietary features into their equipment that lock you into their equipment. So they took this open standard, made a tweak, made a sell. Now all of a sudden you're locked into their infrastructure. So that's where we get brand names and certain features that, all of a sudden now your fleet is all brand X or brand M, as we say. So again, we said DMR is a digital-only modulation, which means it differs from analog in a bit because it's an all-or-nothing type of transmission. And thanks to the error correction we just talked about, you can maintain a solid voice communication when the signal gets weak or has bit errors because you have error correction in the protocol. The problem, though, is for all of us who are familiar with satellite TV or Sirius XM, or even listening to any other type of digital transmission, it's an all or nothing system. Once you've broken that threshold, you've kind of gone over the cliff. Whereas in an analog world, you can listen through the static. Once you hit that threshold where the signal can't be put back together again, you are going R2D2, you are just breaking in and out, or you lose the transmission entirely. So it's either you can listen or you can't hear anything. So that's one of the drawbacks when it comes to digital modulation. Again, that's true for P25 and NXDN as well. So just like P25 and NXDN, DMR has multiple layers in its architecture. They have a common air interface, or a CAI. So the 3 layers that are part of DMR is layer 1, the air interface or the physical layer. This is the layer that you can, kind of hear over the air. It's the physical layer. It's the bits, the data noise. It's everything that's being sent over the air and can be received. Layer 2 is your air interface, or your data link layer. And this handles a logical connection and hides the physical medium from all the upper layers. It's kind of the go-between. Layer 3 is your air interface control layer, or the CCLs. This is basically the base station activations and deactivations, establishing and terminating calls, setting up individual or group transmissions, destination addresses, and all the other behind-the-scenes stuff that make the calls work. So all the layering, all the directions and whatnot. And again, we have images of the control plane diagrams and all the stuff that we've copied off the Etsy website. And you can find those again at scannerschool.com/session55. So DMR, the standard itself, is broken into 3 tiers. Now again, this is all part of the standard. Tier 1 is license-free use in the European PMR 446 band. It's point-to-point, simplex, no repeaters allowed. A 0.5 watt ERP, and no repeaters, no telephone interconnects. You must use the fixed antennas on top of the radio, and this is suited for personal use, recreation, or small retail. Do not require a large footprint. So for those of us in the States, think MERS, think FRS. This is kind of the European standard, and it's a digital transmission instead. Tier 2 is a licensed conventional radio. Again, it covers from 66 megahertz to 960 megahertz in the European spectrum. Again, this is a European standard, so we're looking at European frequencies in the standard. So these are targeted for those who need more spectrum efficiency, more voice features, higher power, and it does require TDMA 12.5 kilohertz bandwidth. So this is more for your commercially licensed type of use. Now, Tier 3, this is what we're going to talk about next week. This is for trunking. Again, same frequencies as Tier 2, 66 to 960 megahertz. Again, uses TDMA. It uses the advanced voice features. It adds short messaging limited to 128 characters and also 288 bits of various formats, data formats. But again, your trunking, capacity plus, connection plus, that all happens in the Tier 3 world. So again, we'll talk about that next week. So let's talk about conventional systems. A single site, basic single site setup conventional is for a small number of users. You can also link 1 to 15 sites together, and that's considered an IP site connect. And these are categorized as Tier 2 DMR sites. So when it comes to programming DMR into your scanners, for a conventional, it's pretty straightforward. You need a radio capable of DMR. You need to know the receive frequency. Optional, the color code. You may need the time slot, but the radio should be able to figure that out for you. And if there's any talk groups, you'll need them as well, so that you get the right system. Because you can have talk groups on conventional frequencies in DMR. If you don't program the talk group, you'll hear everything that happens on that frequency. So again, you can have multiple frequencies on the same. You can have multiple talk groups on the same frequency. So what scanners support DMR? Now, if you have an older GRE or Radio Shack radio, you may be able to upgrade using the Whistler upgrade program. It's called the Whistler Official Upgrade. So the GRE PSR 800, the Radio Shack Pro 668, and the Pro 18. If you have the Whistler 1080, the 1088, or the WS 1095 or the 1098, you can upgrade for free by going to Whistler's website and just downloading the free patch. Out of the box, Whistler TRX and TRX1 and TRX2 will do DMR out of the box. Now, if you have a Uniden, you will need to pay for an upgrade. Uniden's BCD 436 HP, 536 HP, SDS 100, the new SDS 200 probably, the BCD 325 P2, and the BCD 996 P2 will all support DMR with a paid upgrade. So this was your very simplified crash course in DMR. I know it's a little bit technical. I know I breezed through a lot of stuff, but the point is to get through it without putting you to sleep, because a lot of this material is dry, and I apologize for it. That's why we kind of just skim the surface here. Next week, we'll have a little more fun with the trunking stuff. I always find the trunking stuff a lot more entertaining than the conventional and learning about the theory. So before we close out, I want to thank our Patreon supporters, Mark Beebe, Kenneth Fowler, MT Bono, James Felling, William Arcand, and Ken Newberry. Guys, thank you so much for your continued support. If anybody wants to help support Scanner School and become a Patreon supporter, you could do so by going to scannerschool.com/support. And at the $5 pledge limit, you will have early access to the podcast. You don't have to wait every Tuesday for a podcast. You can get it a couple of days earlier by becoming a Patreon supporter. Now, again, you can also support Scanner School by going to scannerschool.com/support. We have other links in there for software. If you're an Amazon shopper like I am, I think I get 4 or 5 deliveries a week. You can even shop on Amazon and support the Scanner School podcast. So, again, next week we're going to be talking about DMR trunking and the 3 main trunking protocols when it comes to DMR. So with that, I'm going to say thank you so much for listening. I know this session was a little bit dry. I do apologize for it, but we had to get through it so we could talk about next week's trunking on DMR. My name is Phil Lichtenberger. This is Scanner School, a podcast where we teach you everything you need to know about the scanner radio hobby. I want to say thanks again for listening. And 73, this is W2LE, and I am clear.